Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 60 in physics series, where I am trying to help you to score maximum possible marks in your upcoming KCET 2025 exam. And if you are following our channel, then you must know that we have already completed a lot of chapters. Those chapters will be revised on time, but currently we are doing system of particles and rotational motion. The chapter is completed. I have completed the chapter yesterday, so if you have not watched that, you can stop this video and watch this video before watching the PYQs. And if you are confident with this chapter, then you can continue watching this video. Rotational motions, PYQs. Also, every Sunday we are doing KPL. Tomorrow will be KPL number 11. We have already completed 10 previous KPL. If you are wondering what is KPL, KPL is KCET Premier League, where I am giving you 30 questions to score maximum possible marks. This week's KPL will be based on the chapters, as I mentioned yesterday, work energy power and system of particles rotational motion, also from your second PU current electricity. Okay, so let's start with this chapter. Previous year questions of system of particles and rotational motion. Also, if you want to download the KPL question paper, previous question papers, also upcoming question papers, you have to join our WhatsApp channel. If you have not done so, please go to WhatsApp channel given the link below. Join our WhatsApp channel so that you don't miss out on any updates. Whenever we are posting a question paper, you can download the question paper from our WhatsApp channel. Right now, let's start with the question of 2023. 2024 question paper I have already solved yesterday. There was only one question, and there are some questions which was already solved during our class, but again we will solve those questions. Also, I have excluded all the deleted questions or deleted portion questions, okay, from this chapter. For example, parallel axis theorem, perpendicular axis theorem, those are now deleted, so I have not included those questions in our discussion. Okay, I have added some extra question end of the session. When all the previous year questions are over, I will be solving some extra questions so that you are confident that you can handle this chapter. Right, let's start. The moment of inertia of a rigid body about an axis does not depend on its shape, depends on the position of the axis of rotation, does not depend on its size, does not depend on its mass. So if you remember about yesterday's discussion, okay, it does depend on the shape, it does depend on its size, it does depend on its mass, okay, and it also depends on the position of the axis of rotation. So option B is correct. Does not depends are incorrect because it actually depends on them, so they are not correct. Right, now let's move on to the next question. The center of mass of an extended body on the surface of the earth and its center of gravity. So what they are saying center of mass, okay, of an extended object. Extended object means object is not a point object, okay, on the surface of the earth and center of gravity. So basically what we are trying to do, we are trying to compare center of mass and center of gravity. And what are the options given? Can never be at the same point. It can be at the same point depending upon certain situations, but can never be obviously not correct. Are always at the same point, no, for any size of the body, that is also incorrect. If the body is small, then they will be at the same point, so this is also incorrect. Center of mass coincides with the center of gravity of a body if the size of the body is negligible as compared to the size of the earth or radius of the earth. So basically, if the size is very small compared to the size of the earth, then we can say that gravitational acceleration is uniform or the gravity is uniform. Then center of mass and center of gravity coincides. Okay, so correct option is option C. You can check option D as well. Are always at the same point only for spherical bodies. Yes, for spherical bodies they are at the same point, but not only for spherical bodies. Any body whose size is very small compared to the size of the earth can be considered under uniform gravity, and we can consider them to be center of mass and center of gravity are at the same point. Okay, the angular speed of a motor wheel is increased from 1200 rpm to 3120 rpm. okay, in 16 seconds. The angular acceleration of the motor wheel is, okay. So if you remember in your PU1 model question paper, when you were in PU1, there was only one model question paper. There were similar questions there, okay, and many of you were struggling to solve this question, okay. It was a 2 mark or I think 3 mark question, okay, where it came from this rotational motion chapter, and it was a numerical question, 3 marks numerical question, okay, and most of you are struggling to solve this question. So how can you solve? Now remember that during that stage you have to show all the steps, you have to show all the methods to get full marks, but in this case if you just correctly find the value, that is sufficient, okay. So how can you solve that? First let us, the values are given, okay. Initial value was 1200, final value was 3120. So what is the change? Change in rotational motion in RPM unit is given by 3120 minus 1200, okay. This is RPM unit, okay. Why I am saying RPM unit, it will be clear in a while. So it will be 18 or 1920, right? So it will be 1920, okay. Best way to check is that if you add these two, you should get this, okay. So this is the RPM unit. Now RPM unit is not useful, okay, when we are checking the answer, because answer is given in radian per second square, okay. So if you remember in linear motion it was meter per second square, in angular motion it is radian per second square. If the same problem was given in linear motion, it would have been very simple question, maybe class 9th or 10th level question. But in rotational motion this question is valid, because first of all you have to convert this RPM into radian per second. Basically that is the main objective of this problem. So if you remember our discussion that when an object rotates for one complete single rotation, okay, then that rotation is basically how much angle? So this, if you see, this is like a clock hand, it rotating like this. So once it reaches here, the total rotation is this pi angle, another pi angle. So total angle of rotation is 2 pi. Okay, so one rotation, RPM means rotations per minute, right? So total number of rotation is total rotation in one rotation means 2 pi. Right, so you have to multiply with 2 pi, but it is mentioned that rotation per minute. So per minute you have to convert it into seconds. So to convert it into second, you have to divide by 1 minute equals to 60 seconds. So you have to divide by 60, right? So now let's cancel whatever can be cancelled. 3 6 is 18, 3 2 is 12, 32 times 2 pi, so 64 pi. 64 pi is the change in the angular speed, and what is the duration? Duration is 16 seconds. So angular acceleration is change in angular speed divided by the time, that is 64 pi divided by 16. So it will be 4. So 4 pi. 4 pi. Now our unit is radian per second square. We have converted into radian, right? So we have converted it into radian per second. Okay, so we are dividing it with another second, that's why it's radian per second square. Okay, so this is 16 seconds, this is already given in seconds, so no worries, we can simply convert it and we can find the answer. So follow the step-by-step method so that you can get the correct answer for such questions. Okay, if you follow the steps. There is one more question in the previous year based on the similar concepts. Okay, we'll see that. Now let's look into question number 4. Two particles which are initially at rest move towards each other under the action of their mutual attraction. If their speeds are v and 2v at any instant, then the speed of center of mass of the system is. So what was the initial speed of the system? Initially they were at rest. Okay, what is the external force acting on the system? External force acting on the system is 0 because they are getting attracted by their mutual attraction. It can be because of they are charged, maybe because of their mass. Because there is no external force, it is only the internal force. So attraction or repulsion between objects in the absence of any external element is considered to be an internal force. So no external force is acting on the system. So basically this is this system is void of any other external forces. So from the first law of motion, its center of mass will remain stationary. Okay, it's remain stationary as it is, and it will not move, so its speed will be 0. Right? So center of mass will not move unless and until some external force is acting on the system. If external force is acting on the system, then it behaves just as like a single particle having the mass of all the objects. So you can even calculate the acceleration of center of mass. Okay, if you know the location, then you can find the new location of center of mass as well. But in this case, no external force is acting, so you don't need to worry about entire question. You can simply say because the system was initially at rest, the center of mass was at rest, and even if they are started moving, because they are moving under the influence of their internal forces, so the center of mass will remain stationary, so it will not move. Okay, now a particle is moving uniformly along the straight line as shown. So here a particle is moving along the straight line, along this straight line as shown. Okay, so this is moving in this direction, right? During the motion of the particle from A to B, during the motion of the particle from A to B, the angular momentum of the particle about O, angular momentum of the particle about O will increase or decrease. Okay, so what is angular momentum? Angular momentum is given by L is equal to R cross P, if you remember. Okay, now object is moving with uniform speed, right? So uniform speed means uniformly means uniform speed. That means V is constant. V is constant means P is constant. P is not changing. Now what about this R? What is this R? Is it the position vector? First of all, this is not the position vector. R is basically this distance. Okay, this vector, this is R. Okay, R is not the position vector, it is the perpendicular distance between the point and the line through which the object is moving. If the object is moving in this line and our point is here, then we will only consider this distance. Okay, this is the perpendicular distance. We draw a perpendicular in the line of motion, and whatever distance it is, that is called that will be our R. Okay, so in this case R is constant, R is not changing. If you see, this distance will remain same throughout the motion. If you consider this parallel line, okay, this distance will remain same throughout the motion. So basically you can consider this to be a two parallel railway lines, right? So this distance from this point will remain constant, so you can say that R is also constant here. So R is also not changing, so angular momentum will remain constant. Okay, this is basically a conceptual question where they might confuse you. Okay, what is R? R is not position vector of the object, it is the direct distance between the point and the line of motion. Okay, if the line of motion is curvilinear, then R is changing for some time and it will vary. Okay, but because R is constant in this case, because the object is moving in a straight line, so we can say that it will remain constant, right? Now next question, two balls are thrown simultaneously in air. Okay, the acceleration of the center of mass of the two balls when they are in air. Two balls, so we have two balls, both are thrown in air after with some speed, initial speed. Okay, when they are in air, what will happen to their center of mass? What is the acceleration of their center of mass? Suppose the center of mass is here. Okay, center of mass is here, so what is the acceleration of the center of mass? Center of mass will be accelerated downward with the gravity, with the gravitational acceleration g, right? There is no other force acting on this system, so it will simply be g. Okay, it is equal to g. Okay, this does not depend on the masses of the balls. Okay, because acceleration, gravity only is constant for all the objects, and you can consider gravity is uniform in this case, so it will only having the acceleration equal to g, nothing else. Okay, all the options you can read, they are incorrect. Now question number 7, So which of the points likely the position of the center of mass of the system shown in the figure. So there is a system shown. Okay, this came in 2016. Okay, there is a system shown here, and they asked you which point likely to be the center of mass. Now as you can see that here we have a box. Okay, empty box. Okay, and it is diagonally filled with sand. Okay, and remaining half is air. Okay, so this portion is heavy, this portion is light, right? So where is the likely position of the center of mass of the system? So as you can guess, because this is a mass distribution is not uniform, obviously center of mass will not be at the center. Okay, even though this is not properly aligned, if they have given you properly aligned things, you might think, okay, center may be the center of mass. Not always. It is always towards the heavier portion of the object. You should remember that center of mass is always towards the heavier portion of the object. So in this case, heavier portion is sand, and only one point inside that region. Okay, so likely center of mass should be at D. In fact, this is not correct. D should be somewhere, exact center of mass should be somewhere here. Okay, not in this end, it will be somewhere here, but we can consider that they have said likely to be. So likely to be from this given options, likely option is option D. Okay, point D. So point D is option B. So be careful. Okay, they have given ABCD, and then again they have given ABCD. So first ABCD is the point, second ABCD is the option. So which option is correct? Option should be correct with point D. Point D is given in option B. Okay, so option B is correct. So in some cases maybe they will give you 1, 2, 3, 4. So in that case you have to choose the correct point and then answer it. Okay, and so that's why they have changed the order as well. They have not given A for A, B for B, C for C, D for D. So they have changed the order so that you may be confused. Okay, so now you should remember that it should be closer to the heavier point. Okay, and it should not be at the end of the heavier point as well. Okay, unless and until it's a super heavy object and it is exactly located at the corner, then only it will be exactly at the corner. Otherwise it will be somewhere between the lighter portion and heavier portion, but it should be closer to the heavier portion as compared to the lighter portion. Okay, now question number 8. Moment of inertia of a thin uniform rod rotating about the perpendicular axis passing through its center is I. Now this question is not based on parallel and perpendicular axis theorem. It is simply based on the concept of moment of inertia. Okay, so the moment of inertia of a thin uniform rod rotating. So there is a thin uniform rod. Okay, rotating about the perpendicular axis passing through its center. Perpendicular axis passing through its center is I. Okay, so what is the I? If the length of the rod is L, then we know that this I is nothing but 1 by 12 m L square. It is very important to remember this value. Now if the same rod is bent into a ring, now you take this rod, bent it into a ring. Okay, and its moment of inertia about its diameter in the ratio about this diameter is I dash. So now the moment of inertia about its diameter is I dash. Now if the diameter is R, okay, if the radius is R, then we can write this I dash to be half m R square. If you remember, these are the formulas I asked you to remember, right? So these are the things that you have to remember. And its moment of inertia about its diameter is I dash. Then the ratio of I by I dash. So first of all, the same rod is now bent into a ring. So same rod bent into a ring means the perimeter of the ring should be same as the length of the rod. Right? So very simple, if you take the rod and then if you bend it, the same length is now bent into this ring. So the perimeter of the rod should be equal, perimeter of the ring should be equals to the length of the rod. So what is the perimeter? Perimeter is 2 pi r and length of the rod is L. So this is the first thing that we have to write. Now next, what we are going to do, we are trying to find I by I dash. So let's do that. I by I dash. Okay, I by I dash equals to 1 by 12 ml square divided by half m r square, right? Or this 12 will come down, this 2 will go up, so it will be 2 by 12 mm cancels. Mass of both of the rods will be same, right? Object is not we are not cutting any pieces, so mass should be same in these cases. Now what is L? L is 2 pi r, so I am putting the value of 2 pi r here, whole square divided by r square. Okay, so it will be 1 by 6, so 1 by 6 times 2 pi r means whole square means 4 pi square r square divided by r square. Now r square cancels, you will get 2, here you will get 3, so 2 pi square divided by 3. Okay, so I by I dash is 2 by 3 pi square, right? 2 by 3 pi square is the correct answer. Simple question, not too much complicated. Now let's look into this question. A force F equals to 5I cap plus 2J cap minus 5K cap acts on a particle whose position vector is R equals to I minus 2J cap plus K cap. What is the torque about the origin? So they have asked you to find the torque. Okay, what is torque? Torque is R cross F. So basically they asked you to find the cross product of these two vectors. So what is R cross F? We know that cross product can be written like this: I cap, J cap, K cap. Okay, R is 1 minus 2 plus 1 and F is 5. If you want a detailed video about cross product, don't forget to mention that in the comment. I will do it. Okay, I have already explained it once. Okay, this is a simple determinant. First you have to write the k cap, then you have to write the first vector, coefficient of the first vector ij k cap in that order, then you have to write the component of the second vector in that same order and then you have to find the determinant. The way you find the determinant. Okay, so first you cross this and this, right? And then you do the cross multiplication. This times this, minus 2 times minus 5 is 10. Okay, minus, so you shift from here to here and then do a cross multiplication again. So 2 times 1 is 2. Right, now some students use a negative sign here to do the second level. I don't do that. I do it in a proper way. That should be the proper way. Okay, now we were at 1, we left at 1. Next we will cover J. Next we will cover J cap, whatever is there, and first column is anyway it is covered, so we will cover the J1. Now we will start with where we left. Where we left with 1, so 1 times 5 is 5 minus 5 times 1 is minus 5, right? Now where we ended here, again we ended at 1, so again for the last case K cap, what we will do, we'll cover the K cap 1 and we were now at 1, so 1 times 2 is 2 minus 5 times minus 2 is minus 10, right? So 8 I cap plus 5 10 J cap plus 2 plus 10 12 K cap. Okay, so 8 I cap, I think I made some mistake. No, this is the correct answer. 8 I cap plus 10 J cap plus 12 K cap. Okay, so this should be the correct answer. So I hope you are familiar with this determinant method. If you are not, you have to practice a little bit more of determinant so that you are perfect at cross product as well. Now let's do one more question. So I said there are two questions came from the similar formula. So this is another question. A rotating wheel changes angular speed from 1800 rpm to 3000 rpm in 20 seconds. What is the angular acceleration? Same question. You saw that question came in 2021. Now 2014 also similar question came. What is the question? So initially it was 1800. Finally it is 3000. What is delta omega? Delta omega is 3000 minus 1800, that is 1200 rpm. Now what we have to do, we have to convert it into radian per second. So how can we convert into radian per second? We just simply multiply by 2 pi, divide by 60 to convert it into radian per second, right? You remember this process? So now it will be 40 pi. You do the multiplication, you will get 40 pi. Now what you have to do, 40 pi radian per second. This is the change in angular speed. So alpha is given by change in angular speed divided by time, that is 40 pi divided by time is given here is 20 seconds, right? So 20 seconds you will get 2 pi radian per second square. So 2 pi radian per second square is the correct answer, right? Now let's move on to the next question. A body having moment of inertia about its axis of rotation equal to 3 kg meter square. It is rotating with an angular velocity of 3 radian per second. Kinetic energy of this rotating body is same as that of the body of mass 27 kilogram moving with velocity v. The value of v is. So first of all, for first object, moment of inertia is given. So the first object I is given 3 SI units, okay? For the first object, the angular speed is given, okay, it is 3 radian per second. And for the second object, mass is given, okay, 27 kilograms. And they have asked you to find what is the velocity. Simple question. And they both have the same kinetic energy. Now if you remember the comparison between linear and angular motion, what is the kinetic energy in angular motion? Kinetic energy in angular motion is half I omega square, right? What is the kinetic energy in linear motion? Linear motion is half mv square. Now both of them have same kinetic energy, so I have written the equal sign in between them. So now we have to simplify this. Okay, so first of all, half will cancel from both sides. I is given 3, omega is also given 3, so 3 square, m is given 27 v square, right? So 3 times 9 equals to 27 v square. So v square is equals to 3 9s are 27 divided by 27 cancels. So v square equals to 1 or v equals to 1, plus minus 1 actually, but we are only interested in the magnitude. So correct answer is 1 meter per second square. Okay, it can be in this side or that side, whatever positive or negative you consider, but the magnitude will be v is equal to 1 meter per second. So correct answer is option B. Simple question. I hope you enjoyed this. Now next question. A body having moment of inertia. This is the same question, I guess. Yes, this is the same question. So answer will be option B. Now question number 13. The closest and the farthest distance of a planet from the sun are respectively r1 and r2. Angular velocities are respectively omega 1 and omega 2. Then the ratio omega 1 divided by omega 2 divided by omega 1 equals. So as we know that suppose this is the distance r1 and this is the planet, okay, and they have said that at r1 the angular motion is, angular speed is omega 1, and at some distance r2 it is omega 2. So this is omega 1, this is omega 2. Okay, so we know that angular momentum of a system is conserved, right? So if the omega if the angular moment of inertia at this position is I1, at this position is I2, then we can write that I1 omega 1 should be equals to I2 omega 2. Okay, so what is I1? Now because this is a system, its moment of inertia will depend on the position. So first it will be mass of the planet is same, right? Mass of the planet is same, and if you consider this is your center or axis from which you are measuring, then I1 will be mr1 square, right, times omega 1 equals to mr2 square omega 2. This question is based on the conservation of angular momentum principle. Okay, so m cancels, so omega 1, or what is the question, omega 2, sorry, so omega 2 divided by omega 1, that means we are taking this on that side, so this will come this side, r1 square divided by r2 square. Okay, r2 square divided by r1 r1 square divided by r2 square, right? So this is a very interesting question. Let's move on to the next question. Two bodies of mass 6 kg and 4 kg have position vectors 5i plus 2j plus 10k and 10i plus 2j plus 5k. The position vector of the center of mass of this system is. So two masses are given. So what is the meaning of this? Let's understand. Two masses, one is 6 kg, it is located here. So located here means, what is the meaning of this? This means that the coordinate is 5, 2, 10. I hope you are familiar with three-dimensional coordinate system. Now another mass is 4 kg and it is located here. So that means its position is 10, 2, 5. This is the position of the two objects, and they have asked you to find the center of mass of these two objects. So there will be CM, VCM. Okay, suppose this is x, y, z, right? So what you have to do, you have to find the position of this VCM. So first we will calculate the x component, xCM. If you remember, xCM is given by sum of mi xi divided by capital M, right? So what is mi xi means? Mi xi means this is mi, this is xi. So mass times x coordinate, 6 times 5, right? Mass times x coordinate plus this times this, 4 times 10. Sum is there, right? Sum is there. That means whatever, how many masses are given, you have to multiply all the masses with their respective x coordinate and then divided by the total mass. Total mass is 6 plus 4. This one is 6, this is 4, so 6 plus 4, right? So 5, 6 30 plus 40 divided by 10. So 70 by 10. So you can see that x coordinate is 7. Now you don't need to solve this question any further because in the given option only one option has 7, so you can blindly answer this is the correct answer. But in case there are multiple cases where you find that there are 2 7s or 3 7s, then you have to solve for the next coordinate using the same method. So YCM, I am giving you the formula. YCM is mi yi by m and ZCM is equal to mi zi by m. So same method, first you take this mass, multiply with y coordinate plus second mass, its y coordinate, okay, add them, then divide it by the total mass. Similarly for z component as well, multiply the two z's, okay, mass and z component, add them and then divide by the total mass. Okay, so also one more for this question, this is very easy question, even without solving you can answer this question. None of the coordinates are negative, so the center of mass should have x, y, z both components. Now if you see all these three questions, three options, only I, K, J, K, I and K, these are given. So one of the coordinate is missing, which is not possible. So only correct answer is option D in this case. So you don't need to solve if the same to same question comes in your KCET exam, but they will change the values so that it will be little bit more complicated than it looks in this question, right? Now let's move on to the next question. A shell fired from a gun at an angle to the horizontal explodes in midair. Okay, so a shell is fired, okay, and it explodes in midair. Okay, then the center of mass of the shell fragments. So center of mass, initially when the shell was moving in this, the center of mass was obviously within this object, right? And as it's moving, it was moving in this path only. Now what will happen to this center of mass? It will move horizontally, it will move vertically down, okay, remain stationary at the place of explosion, move along the same parabolic path along which the shell was exploded. So these are the three options. Obviously we know the answer. It will continue to move in the same path because no external force is applied on the system. The explosion is internal thing, okay, no external force is acting, so it will continue to move in the same parabolic path, okay, under the influence of gravity. Gravity is there, and gravity is like a projectile. It will try to take it in a parabolic path, so it will continue to flow in the parabolic path. So correct answer is option D. Okay, so I hope you enjoyed today's session. I have completed all the previous year important questions as well as some extra questions, and if you excuse me, if you have any questions related to today's lecture, don't forget to mention that in the comment below. I will try to answer as much as possible. Tomorrow's KPL syllabus I have already discussed, and I will see you with the solution tomorrow. Till then, bye.